Okay, so we're going to be talking about the equations of a circle. I've kind of got a rudimentary circle drawn here on this little whiteboard. And the definition of a circle is all points that are equidistant from a given center. So we've used our center at 0, 0, the origin of the graph here. And of course I could pick any point on the circle. I picked one point up here and I drew my radius. In this case, I'm calling my radius C. We'll talk about that in just a second. So you can see we've got our radius coming out, but when I draw down my vertical distance and I draw also my horizontal distance, we get this little right triangle. And when we have a right triangle, we should find out that a squared plus b squared equals c squared. So we've got this connection with the Pythagorean theorem, where we can take and come up with the equation of a circle based on the Pythagorean theorem. Now, how is it based on it? If this is my horizontal length, and we turn that into our x, and this is my vertical distance, and my vertical distance I will consider to be y, then I'm going to change my hypotenuse from c to actually being my radius, and we still have a right triangle, but now we can see that x squared plus y squared has to equal r squared. And that is our basic parent function of a circle. It's in its standard form. So we have x squared plus y squared equals r squared, but in this case, my center is at 0, 0. With 0, 0, we have this basic form. If I adjust that, if I translated that, and let's say that I moved the center of my circle to where I moved left 1 and let's say up 3, and we're going to approximate it to be there. We're not going to change radius. We'll throw a number in for radius in just a second. But if I change that to be -1, +3, when I go and transform my parent function, what happens, we fall into this form, x minus h, where h is the x coordinate of the center, so x minus h squared, plus y minus k squared, where k is the y coordinate of the center, and it's equal to still r squared. So this has basically turned into my horizontal distance plus my vertical distance. So horizontal distance squared plus vertical distance squared should equal my radius squared. With that being said, if I need to then, knowing the center of my circle, and I'm going to go ahead and say that my radius is 5 units long. So if I have x minus h, well, h is a -3. So we would have x minus it's a -1. If I have x minus -1, minus negative is actually going to become a +1. So we have x plus 1 squared plus y minus k. K is a 3, so we would have y minus 3 squared equals r squared, and my radius is 5, so we would have 5 squared, or in other words, 25, that you'll see in just a second. Now, things that we need to point out that we've discussed in the past, because we had minus h and minus k, when we brought our center in, what actually happened is they adjusted from negative, negative, so it became a positive, or minus a positive, which became a negative. You've got to remember that so that when you're bringing these in or taking them out to recognize what the center is, you'll know to make it basically the opposite. So here, if we continue to write this, we would have x plus 1 squared plus y minus 3 squared, and that would equal 25. And there it is in our standard form with a center of -1, 3 and a radius of 5. Now, when we're in that form, Again, we already know what the center is, but if you were given a problem where it was written in standard form and you were asked the question, what's the center? You just look at the equation. Your center is going to be h and k. So we would have the opposite of 1, which would be -1. We'd have the opposite of -3, which would be +3. There's our center. And our radius would simply be the square root of 25, which means our radius would be 5. So from the equation, we can easily, when it's in standard form, we can easily pull the center and the radius by simply taking the square root of the radius. Now, that's when we have the center or when we've been given the equation and we need to find it. We have another version of this if we're given the equation in a different form. So we're going to take a second here and we're going to write an equation on the board so that we can look at this. So if they gave me